So we will talk about today about introduction to Kubernetes. Kubernetes, what's the idea you have in your mind?
Yeah, 1 second. Let me start recording first.
Okay.
Yeah. Okay. Okay. Start.
Getting started guide. Just discuss only about some of the theoretical.
Yeah, it is started. Yeah, it is actually Kubernetes. It's one of the orchestration platform. Yeah. Let me start from Docker. So Docker is one of the containerization option which is available for us. One of the famous one. So Dockers, we can run multiple Dockers in a one node. So those nodes should be managed by someone. For that, we have to have orchestration platform. That Kubernetes is one of the very famous orchestration platform that can manage these Docker containers.
That's right. That's right. It's like more of overall understanding about that Kubernetes. That's very good. Nice. Okay. But Kubernetes is doing a lot more than that. It's an orchestration platform. Okay. But it will do a lot of jobs like maintaining the Dockers, containers, many other containers as well. And it can have its own like kind of an infrastructure is there. We will be discussing about the infrastructure on the Kubernetes, how it is being constructed inside, and what are the components inside of that, how to configure that Kubernetes in a Linux platform, how the dashboard will be looking like, how you are going to manage all the Docker containers inside the Kubernetes cluster. Actually, it is creating a cluster. Cluster is nothing but containing a multiple, like containers in one shot or something. And Kubernetes can be like, it can be running with many master nodes as well. Like it's going to be a master and a slave, like it's called as like a master and a worker nodes, like that it's been called. And there are a lot of mechanisms which we are going to discuss about this in the Kubernetes. Kubernetes is so vast. It takes a lot of time for you to understand in a practical scenario like that. So the lab is about to get ready, so I will be talking about this Kubernetes on the slides only today. Okay. And it may go for maximum 1 hour. I can just say that. Let's see that how much we can able to finalize it with that. And there are, I guess, around 30-40 slides maybe there. We will go through one by one the slides on that. And this is an introduction and the components and the management, and it's talking about the dashboards. And it is talking about a little bit of troubleshooting after that, like something like comprising of all these things. I just made it on this one. So we will talk about that. Why do we require a Kubernetes kind of an environment? Without that Kubernetes kind of an environment, like an orchestrator, what could be the disadvantages we'll be having it? How do we maintain that multiple containers which are getting created automatically? Because we've seen in one other example in the AWS that we can go for an auto scaling like that according to the traffic pattern or the CPU utilization of that certain machines or something inside. You can call the machines as a containers only. Within that, they are increasing their own the CPU getting increased in the sense we require to create another machine or something. So when it is going on an exponential like that, it is keep on getting created on that. How do we going to maintain all of this? How do we maintain? How do we check and the availability of them when something goes wrong? Some of the nodes are getting down. At the time, how the Kubernetes will be removing that particular container from that, like cluster or something like that, and it will try to troubleshoot it out and try to send some kind of an intimations, emails or notifications to the manager, whoever the administrator, whoever is going to be. This is coming under kind of, the troubleshooting point of view under the Kubernetes. Kubernetes is, as I said, Kubernetes is it's an open source platform and it is a free completely. And Google has took that in the sense what he try to make some more of Kubernetes easy and other things they implemented in their own cloud. And whatever it may be, the bigger companies when they start thinking about that, when they putting their own eyes on certain product or something, it'll get a worldwide recognition on that. Like so, Linux has come up. So because of Red Hat has put some kind of the eyes on that, so Red Hat, so Linux has come into the bigger picture on this. Like that, Ubuntu is also like so. Like Kubernetes has also come up into the bigger in the market because Most of the container orchestrations are happening all over the world by the Kubernetes only. And one more is that is called the Docker Swarm, SWARM. That is also a orchestration platform. Like many other platforms are also there. But how come the Kubernetes has come up like so bigger? And everybody is talking about that Kubernetes, and people are putting like, it's a mandatory requirement for the people has to know. The engineers has to know about that, how the Kubernetes has been constructed and maintained and troubleshooted and other things. And also now Kubernetes is a part of the DevOps cycle, development and operations. Even the development people should be knowing about Kubernetes. Operation guys like us, like engineers who are maintaining the networks and all, should be knowing about that Kubernetes. This has come into that very much in demand after that cloud environment has come. Because in the cloud, like exponential of the machines which has been created and many containers has been created as and when required, that we are going for the containers as well. Earlier we seen some kind of a Docker and other things. Like Docker is like which has been constructing a small applications within that with its binaries and libraries included on that, so that movement of the Docker container is so easy between the platforms as well. It's very easy for us to send it from the development to the testing to the implementation to the troubleshooting side. So everyone, no need to construct anything on a base side or something like that, so that the Docker container can be tested and verified or something. So that is the advantages of the containers which we see. So now here we are going for the next level, like next level in the sense how this much of heavy volume of the containers can be managed in an environment where we will be putting everything under one roof. That is nothing but the Kubernetes is going to start with it. We will go by the slide by slide. You can go to the next slide. Click on the next slide.
Oh, 1 second.
Can you make it bigger? Yeah, because if it is a full screen, it's nice.
Yeah, let me share this. No better, right?
Now it's okay. Now it's clear. Let's go to the next slide. Is it coming?
Yeah, this is second slide.
Okay, next slide. Kubernetes is a platform that eliminates. No, you went ahead. This is correct. It's a platform that eliminates the manual process involved in deploying and containerized applications. Before containers came into the existence, the developers and the testers always had a tiff between them. This usually happened because what worked on development side would not work on a testing side. Both of them existed in the different environments. Now, to avoid such a scenarios, containers were introduced so that both the developers and the testers were on the same page. Because there won't be any clashes will happen between the developers and the testers and others. There it comes that Kubernetes is coming. Okay, handling a large number of containers altogether is also a problem. Sometimes while running the containers on the product side, few issues were raised which were not present in the development stage. This kind of scenarios introduced in the container orchestration system. So first of all, we are talking about the base bare minimum necessity things. It's actually not required as such when we talk about the containers in the sense, because the base operating system is there and that itself is enough for us. So containers will take care of them own. And we are moving into the next level. That is nothing but container management. Why the container management is required in the sense, the rise of the number of containers which are with the quantity which we are talking about. Maybe like if it is going around 10,000, 15,000, 20,000 containers need to be maintained in the sense we require a system for that. We require an orchestration platform for that. There, our Kubernetes is coming into that picture. Okay, let's go to the next slide. In this diagram, when multiple services run inside the containers, we may want to scale these containers. Scaling in the sense, that is what nothing but an orchestration can say. Auto scaling, I can say that. In large scale industries, this is really tough to do. That's because it would increase the cost to maintain the services and complexity to run them side by side. To avoid setting up the services manually and overcome the challenges, something big was needed. This is where the container orchestration engine has come into the picture. You can just see this. Multiple services running inside the containers that is going to the multiple departments as well. Like increases in the human resource cost of running the services, increase in the size of bills from public cloud providers, increases the complexity of running something new in the production. Scaling is difficult, very much difficult. Setting up services manually, that is again a view, like it'll take huge lot of time as well for us. Manual work of fixing the node when it crashes. So these are all the things which people will be having, that when there is an exponential growth of the container platform is increasing. So what could be the solution for that? Right. What could be the solution for that in the sense? We will go for something, I guess.
So we have to have.
We require certain kind of, the containerized platform as well as orchestration platform. Like that. So now we are going to discuss something about that. There are two different type of orchestration platforms are there. Docker Swarm is still there, as well as the Kubernetes like. This engine organizes multiple containers in such a way that all the underlying machines are launched healthy and distributed in a clustered environment. In today's world, there are two mainly such engines are there. One is a Kubernetes and another one is a Docker Swarm. This is just a comparison when we're talking about, because Docker Swarm is also being used by certain people. In Docker Swarm, there is no autoscaling. In Kubernetes, we have the autoscaling. In second, there is a good community background is there. Here it is a great active community background is there. Means people are, a lot of developments is happening on Kubernetes. Hello. Hello. So we were discussing about that, comparing the Docker Swarm with the Kubernetes. Okay. So in the Docker Swarm, we don't have any kind of, auto scaling and other things are there. But in Kubernetes, we have the auto scaling. And the good community is there, but still the people are doing a lot of developments as well. But here we have a great active community which is going on. Community activities, I can say. And easy to start as a cluster. But here, difficult to start a cluster. Anyway, but because of the complexity which has been there in the Kubernetes, when it is compared with the Docker Swarm, and limited to the Docker API capabilities. But here, it can overcome the constraints of the Docker and the Docker API here. Does not have so as much experience with the production deployment at a scale. Here we have. Deployment at a scale is more often among the organizations. Means as far as the comparisons takes place between the Docker Swarm and the Kubernetes is a clear best choice which we'll have to go for. And moreover, Kubernetes can be maintained completely with our GUI itself is possible on this. Okay, let's go to the next slide.
A community in the sense that is a development community and all.
Yeah, it's like because of the open source, no, the communities will be like, people will be developing many things and they will be sharing that under one roof. We'll go to that forum and we can pick up many of the details which other people are doing it like. It's like globalized sharing community, something is. Okay, next. Feature wise, when we talk about that, Kubernetes and Docker Swarm, installation of the cluster and the cluster configuration. Installation is complicated in Kubernetes, but once set up, cluster is very strong. In Docker Swarm, its installation is very simple, but cluster is not very strong as such. GUI, Kubernetes got the GUI dashboard is available, but here there is no GUI as such. Scalability, Kubernetes is highly scalable and scales very fast, highly scalable, and the five-fold increase in faster than the Kubernetes. Can say that. And the Kubernetes can do the auto scaling. Docker Swarm cannot do the auto scaling as such. That's the comparisons. And we can go to the next slide. Load balancing, manual intervention needed for load balancing traffic between the different containers and different pods. We'll talk about what is a pod later. Docker Swarm does not auto load balancing of different containers in the cluster. And rolling updates and rollbacks can deploy rolling updates and does not, and it does the automatic rollbacks as well. Can deploy rolling update, but no automatic rolling updates as such in Docker Swarm. Data volumes can share the storage volumes only with other containers in the same pod in Kubernetes. Can share storage volumes with any other containers as well. There are like comparisons when you talk about that pros and cons of the Kubernetes as well as the Docker Swarm is there. Logging and monitoring, inbuilt monitoring tools and logging and other things are there. Third-party tools like Elk and should be used for logging and other things. This is about the Docker Swarm and other things. I guess one more slide is there for feature comparisons. You can go to the next slide. Installations and cluster configurations. Setting up a cluster with the Docker Swarm can be done with a snap of your fingers. Means like very easily you can do that. Only two commands need to be executed. One at the manager end, another at the worker end. Literally that all it takes. After that, you can straight away commence your deployment. It's very much easier. However, with the Kubernetes, the setup is nowhere as easy as a Swarm. Means like you need to run commands to bring up the cluster, then to define your environment, then to define a pod network for containers to interact with each other, then to bring up the dashboard, and finally the cluster will be hosted like. So it is a more complex platform when you talk about the Kubernetes side. Okay, the next one. GUI dashboard is there for us. We can have the GUI dashboard. GUI is basically a dashboard which can be used to control your cluster effortlessly. No CLA commands hassle, no technical efforts, and simple English when professionals from non-technical background can be cope up with. You can get this like, localhost 8001 or some other number, port number, which we are specifying that it can go along with that. And the dashboard will look like this. However, in a Docker Swarm saying that, sorry, we don't have any kind of facilities, means there is no GUI is available on the Docker Swarm. That's all about this slide. We can go to the next one. Next, auto scaling. Clear winner is a Kubernetes. This is because KATS means Kubernetes we call this. Intelligent enough to analyze your server load, scale up or down as per the requirement. There is no need for manual intervention as a big help, because traffic catastrophe can be completely avoided. In Docker Swarm, it's not that case with no help available. Manual intervention is the only way to support your auto scaling. Then auto scaling, you cannot call it as like an auto scaling as such, because manual intervention in the sense we just need to go and monitor the scaling and other thing options and other. So Kubernetes will be the best choice for that. Next, load balancing. At times you need to do manually configure your load balancing settings. Multiple containers are served as in one pod, and each service can be defined as a group of pods. Now the challenge is to get the pods to talk to each other, as they should be easily discoverable. Since the services are used for discovery and not their IP addresses, hence the challenge. But in the load balancing is very simple in Swarm, because it does the auto load balancing, no concept of pods. Hence all the containers discover each other and with the network and IP addresses and other things, which can happen as long as the nodes are connected to the cluster like that. So load balancing things, Swarm is bigger, and other options where we'll be talking about other options like Kubernetes is a better one. We can go to the next slide. This is just a comparison which you're seeing on this one. Rolling updates wins here again. In fact, both KATS and Swarms support the concept of rolling the updates to the containers, performing the rolling updates to the pods as a whole, while Swarm does it containers straight away. Rolling updates is a process of progressively and gradually deploying the updates to the existing apps in all containers. But Swarm is beaten because it does not do automatically rollbacks. Whenever something goes wrong while deploying your updates, can provide an option to roll back to the previous table deployment, but only Kubernetes does auto rollback 1 second. Huh? Okay, I'm sorry. Both KADS and the SWAM provide an option to the rollback with the previous table deployment, but only Kubernetes does the auto rollback in case of failure condition. Master of the cluster closely monitors and update 8 deployments. Something like that. So this is about the rollback and updates and other thing, because it is required for the clusters to need to get updated, or it can be, like rollback when something goes wrong or something. So there's a comparison between the Kubernetes and the SPAN like this. We'll go to the next one. We are going to discuss about only the, like Kubernetes there. Allows us to share the storage volumes between the multiple containers inside the same pod. However, Docker Swarm allows us to share storage volume with any container. Advantage is that storage can be easily mounted on local storage or either on public clouds like AWS, GCP, or even shared network like an NFS. NFS is a network file storage, we call it as like. So this is about the data volumes comparisons. Next. Kubernetes. We'll come to the Kubernetes because this just we seen something about the comparisons between the Docker Swarm and Kubernetes. Docker Swarm, I don't know how many people are using on this. They are all using the Kubernetes only. What is Kubernetes? You see that Kubernetes engine is there in the top, and all the Docker containers are getting managed from the Kubernetes like this. Kubernetes is an open source system that handles the work of scheduling the containers onto computer cluster and manages the workloads to ensure they run as user intents. Being a Google's brainchild, it offers excellent community and works brilliantly with all cloud providers to become multi-container management solution. You can say that, but it is an open source again. Okay, next. Kubernetes features: automatic scheduling, self-healing capabilities, automated rollbacks and rollouts, horizontal scaling and load balancing. Automated scheduling, in the sense, this is the first one. Kubernetes provides an advanced scheduler to launch container on cluster nodes. Self-healing capabilities, rescheduling, replacing, restarting the containers which are died, which are about to get died or died. Automated rollouts and rollback. Kubernetes supports rollouts and rollbacks for the desired state of the containerized applications. Horizontal scaling and load balancing. Kubernetes can scale up and scale down the applications as per the requirements. So these are all the 4 basic features which we talk about in the Kubernetes. We'll go to the next slide. Automatic scheduling. Kubernetes provides the advanced scheduler to launch the container on cluster nodes based on their resource requirements and other constraints while not sacrificing the availability. Self-healing capabilities allows to replace the reschedules containers when nodes die. It also kills the containers that do not respond to the user-defined health check and doesn't advertise them to the clients until they are ready to serve. This we normally see it in the load balancers itself. So it is doing some kind of self-healing capabilities. Automated rollbacks and rollouts and rollback. Kubernetes rolls out the challenges, applications or its configurations while monitoring the application health to ensure it doesn't kill all your instances at the same time. If something goes wrong with the Kubernetes, you can roll back and change. Horizontal scaling and load balancing. Kubernetes can scale up and scale down the application as per the requirements with a simple command using the UI or automatically based on the CPU usage. So these are all the advantages, you can call it as the features of your Kubernetes cluster. Next. Kubernetes architecture. Architecture contains the 2 main components. That is, one is the master nodes and worker and slave nodes. Master node is responsible for management of the Kubernetes cluster. It is mainly the entry point for administrative tasks, all administrative tasks. There can be more than one master node in the cluster to check the fault tolerance. Means we can have some active node and passive node, something like that. They can do some kind of automatic failover or something like that, which we can do that. So mainly for fault tolerance, we'll be doing like you can say that HA, high availability architecture, we can create that. For that, we require some heavy hardware and all. That is a different issue. But it supports that kind of multiple master nodes can be there in one kind of Kubernetes environment. We can see that. Next.
It's like vCenter in VMware, right? It's not like vCenter. I mean, some little bit similar to that, right?
Yeah, you can say that, but here Kubernetes is doing very much of a complex activity. Like because we are all handling the containers only here, not the VMs we are handling. Right?
Yeah. I understood, because thing is VMs are that nothing much to do, because the VM will get hardware also, they will be allocated, but here that is will go through the operating system. So everything that I think this guy has to communicate with the operating system also.
Correct. Yeah, right. That's right. Next. As you can see in the diagram, the master node has various components like API server, controller manager, scheduler, and etcd. They call it as an etcd. So this is nothing but an API server in the master node, and the controller manager, scheduler, etcd. Which component is doing what operations, we'll see. API server is entry point for all REST commands used by the control to the cluster. It's coming from here. And the controller manager, it's a daemon that regulates the Kubernetes cluster and manages difficult non-terminating control loops. Then the scheduler schedules the task to save slave nodes. It stores the resource usage information for each slave node like this. etcd is a simple distributed consistent key value store. It's mainly used for shared configuration and the service discovery. These are all the four basic, the basic components on the master node we will be seeing on the Kubernetes cluster: API server, controller manager, scheduler, and the etcd. API server is an entry point. Controller manager is a daemon regulating the Kubernetes cluster. Scheduler schedules the tasks to slave nodes, stores the resources usage information for each slave node. etcd is a simple distributed consistent key value store, mainly used for sharing configurations and the service discovery. Okay, this is about the infrastructure of our Kubernetes master. Next. Worker and slave nodes. Worker nodes contain all necessary services to manage the networking between the containers, communicate with the master node, and assign resources to the scheduled containers. This is a worker node. We have the Docker containers. These are all the Docker containers you can call. And kubelet. We will see the kubelet. What is the kubelet is that? And then kube proxy. Then the pods. These are all the pods. The pods in the sense pod 1, pod 2, somewhere other it goes. These are the Docker containers. So this is about the worker and slave nodes which we see. We will see what is a Docker container. We know about the Docker container already. What is kubelet, what is kube proxy, and what is the pods? We will see in the next one. Next slide.
Let's say that here we have the architectures. We have when we look at the architecture, we can see that worker nodes are there and master node is there, right? Master might be one or two. I mean, there should be cluster. I mean, few Kubernetes masters.
Yes.
Am I correct? Okay. This worker node in the sense that we hosted the Docker containers, right?
Yeah, Docker containers, yes, correct.
Docker containers or the host which we hosted Docker containers?
See, this is going to manage the certain things, like when it has been getting included. The Docker containers are getting included under the master container, nodes in the sense they are called as like a slaves. And that slaves will be managed by the Kubernetes cluster in the form of with these are the things which we are going to discuss now: kubelet, kube proxy, and the pods like that. So pod is nothing but like more of the containers will be kept inside, and it will be taken as like a pod, POD. Then we will see what is the example, what are the explanations about that. Docker container, Docker runs on each one of the work nodes and runs in the configured pods. Kubelet gets the configuration of the pod from the API server and ensures that described containers are up and running. Kubeproxy acts as a network proxy and a load balancer for a service on a single worker node. Pods is one or more containers that logically run together as on the nodes. So pod is nothing but multiple containers will be there in one pod. And the pods will be like Kubeproxy acts as a network proxy and a load balancer for a service on a single worker node. Kubelet get the configuration of the pod from the API server and ensures that described containers are up and running. And the Docker containers, we see that. This is how the worker will be looking like from the master to the worker node, like this. So we will see some, multiple things on the next slides, which will help you in understanding how the worker node is going to be like. So this is the master node, and this is the worker nodes here. And this is your Kubernetes master is talking to them. It comes in this way. So communication happens between the worker nodes and the master nodes as and when required. The command which comes from the API, which comes from the outside, the commands which are given from the outside node or something. So that is being controlled by this worker nodes by this master node. You can see that. We'll see in the next slides. Kubernetes overview, that's what we just seen that already. Anyway, open source container management tool which automates the container deployment, container descaling or scaling, as well as the container load balancing. This everything has been done by the Kubernetes. What is Kubernetes? Kubernetes architecture. Kubernetes architecture written on Golang, that is a language. Huge community because which was developed by the Google and later donated to the CNCF. Something is a forum is there. Can group n number of containers into one logical unit for managing and deploying them. This is about the one which we are going to see it in the much larger scale in the next coming up slides. You can see the next. So this is how the architecture is looking like. You see that. This is a user, he using the CLI or API or through the dashboard, he will be talking to the master node. In the master node, what is there? We see what is the controller. We have seen the API server and we seen the scheduler. And the key value store is that is nothing but the etcd. Whenever there is a command line that is coming up, or the API which is coming up, or through the dashboard, the action which is coming up, which will be maintained by this API server, and it has been distributed to the particular nodes or the worker nodes. You can just call it as like this. This is the worker node, this is the worker node, and this is the worker node. And this node is containing the Kubeproxy is there, Kubelet is there, and the pods are there, real containers which are there inside. So you can call it as this is a one worker node, second worker node, third worker node. So this API server is going to do all the controlling and other things. Which worker node need to be talked, which pod need to be contacted, how to schedule this, all these things. Scheduling is nothing but like which we are having kind of a configurations and other things to push and pull, something like. So these are all the master node is going to do. So where the command is coming from, it is coming from the user directly. Okay, we will see one by one on the next slides. Master nodes, worker and slave nodes, distributed key value store. It is an entry point for all administrative tasks, which is responsible for managing the Kubernetes cluster. And there can be more than one master node in the cluster to check for the fault tolerance. More than one master node puts the system in high availability mode, in which one of them will be the main node, which we perform all in the tasks. For managing the cluster state, it uses the etcd, in which all the master nodes are connected to that. Cluster state, when we talk about it, these are all the Kubernetes architecture has following components as such. Master node, worker and slave node, which we've seen already. Distributed key value store. That is nothing but our, key values are going to be stored on that particular etcd. It is an entry point for all administrative tasks, which is responsible for managing the Kubernetes cluster. That is nothing but the master node which we talk about. There can be more than one master node in a cluster to check for a fault alerts. That is nothing but a HA. We are revisiting that fundamentals again. More than one master node puts into the system in a high availability mode, in which one of them will be the main node to which will perform all the tasks. We can control that. For managing the cluster state, it uses the HCD, in which all the master nodes are connected to that. So next, we'll see. What is the controller manager? This is nothing but a controller. This controller, it's also called as a controller or a controller manager, we can call it. It is a daemon which regulates the Kubernetes cluster, which manages the different non-terminating control loops, which manages the different non-terminating control loops. And it also performs the lifecycle functions such as namespace creation and lifecycle, event garbage collection, terminated pod garbage collection, cascading deletion garbage collections, node garbage collection, and etc. This is more of a controller. It's a lifestyle functions it is doing. Basically, a controller watches the desired state of an object. It manages and watches their current state through the API server. If the current state of the objects it manages does not meet the desired state, then the control loop takes the corrective steps to make sure that the current state is the same as the desired state. What is it doing? It's running like a daemon. Daemon is nothing but a service, which we know that, like a HTTPD, FTPD, like that the service it is running on this. And this is the controller, which terminating the control loop and other things, non-terminating control loops or something. It is also performing the lifestyle functions as namespace creation and lifecycle. Namespace creation in the sense identifying your pods and other things. Event garbage collection. This is normally required for us. Terminated pod garbage collection. Cascading deletion garbage collection. Node garbage collection and other things it does. Basically, a controller watches the desired state of objects it manages and watches their current state through the API server. If the current state of the object it manages does not meet the desired state, then the control loop takes corrective actions to make sure that it comes back to the desired stage. It's nothing but like a more of a controlling. That's why it's a controller. It's called as. Next, we can see the API server. API server performs all the administrative tasks through the API server within the master node. In this, REST commands are sent to the API server, which validates and processes the requests. After requesting, the resulting state of the cluster is stored in the distributed key value store. So API server, which will be taking all the API commands from the master nodes and the like, performs all the administrative tasks through the API server within the master node. In this, REST commands are sent to the API server, which validates and processes the requests. After requesting, the resulting state of the cluster is stored in the distributed key value store. Next, we'll see about the
that means we can send a script even, right? Directly. Like
API is nothing but application programming interface, which we through that we'll be sending some certain scripts on this, requests will be sending on that, and it will be processing and it will be doing certain actions based on that. Yes. A bit complex only what to do. Kubernetes is like this. Scheduler. Scheduler schedules the task to the slave nodes. Here we are going to talk to the end user in the sense end containers and slave nodes. It stores the resource usage information for each slave node. It schedules the work in form of pods and services. Before scheduling a task, the scheduler also takes into account of the quality of the service requirement, like data quality, affinity, anti-affinity, and extra. Means this scheduler is going to talk to that all the guys, worker nodes like that, if you just say that. It takes talks to the slave nodes, stores the resource usage information for the slave node. It schedules the work in the form of pods and services. Before scheduling the task, the scheduler also takes into the account of quality of service requirements, data quality, data locality, and affinity, and anti-affinity, and other things and all. So there are three components in the master node. One is a controller, which controls everything. Then the second is the API server. Through that script and other things are sent. Scheduler, which directly talking to the worker node from whatever it got, all this. And the key value store is storing all the informations about the master nodes and the configurations and other things that is keeping it. So overall, this is like a master node, we can call it as. Next, we will see etcd. etcd is the last one. Stores the cluster state. It can be part of Kubernetes master or it can be configured externally. etcd is written in a Go programming language. In Kubernetes, besides storing the cluster state based on the Raft consensus algorithm, it is also used to store the configuration details such as subnets, configuration maps, secrets. Secret is nothing but a password and other things, etc. Raft is a consensus algorithm designed as an alternative to Paxos. The consensus problem involves multiple servers agreeing on values. A common problem that arises is the context to the replicable state machines. Raft defines three roles. One is a leader and a follower and the candidate, and achieve the consensus via the elected leader. You can just leave this. You can take it as like that. It is going to store the key value about the cluster state. What is the cluster state? Whether it is running, not operating, or what are the data? It may be in a master node. Okay, it can be part of the master node, or it can be run it in the externally also. It is written in a Go programming language. You can take it in that way. What information it contains? Subnet information, configuration maps, and secrets. These are all the information, so you can find it in the etcd. Clear?
Yeah.
So master node is containing near about 3 or 4 components. One is a controller, second one is an API server, third one is a scheduler, fourth one is an etcd. These are all need to be there. Or etcd can be outside of the master node also. It's possible.
Yeah.
Okay, next. Okay, do one thing. Just go through the slides once more so that you will get some idea. Then we will continue with the work nodes. Okay.
Okay.
So until now we've seen that master node. What are the components inside that, and what is the work of that each and everything? What is the functions of that? Now we are going to see that worker node. Worker node are previously called as like a family. They are called as like a minions.
Yeah.
And you see that there is an external world coming into the kube property, then the kubelet, then the pods of it. It is a physical server, or you can say a VM, which runs the applications using the pods, pod scheduling unit, which is controlled by the master node. Means I'm talking about a worker node. On a physical server, pods are scheduled. For accessing the applications for external world, we can connect to the nodes. Container runtime, kubelet, kube proxy, and pods. This is nothing but like we are going to contain. These are all the things which are containing inside the worker node. This entire thing is called as a worker node. It's called as a worker node. External world is coming inside. Like. So through the proxy, it can be like load balanced or something other. We can do that. And it can be accessed from this, and the pods are accessing through this external world like this, through this, and we can see one by one on the next coming up slides. You already seen that anyway. Next, container runtime. To run and manage a container's lifecycle, we need a container runtime on the worker node. Sometimes Docker is also referred as a container runtime. But to be precise, Docker is a platform which uses containers as a container runtime. Kubelet, it is an agent which communicates with the master node and executes on the nodes or the worker nodes. It gets the pod specification through an API server and executes the containers associated with the pod and ensures that containers described in those pod are running healthy. That is nothing but like in between, inside the worker node, we can just say somebody who is controlling all this. That is nothing but the kubelet. It is an agent which communicates with the master node and worker nodes like that. And it gets the pod specification through the API server and executes the container associated with the pod and ensures that the container described in this pod are running and healthy. This is about that. Then we will be seeing something about the kube proxy next.
Simply, it's a communication agent.
Yeah, I can take it like yeah. It takes all the things from the outside from
API
the node, yeah, and making it over that getting executed inside of this worker node. Next, kube proxy. It runs on each node to deal with individual host subnetting and ensure the services are available to the external parties. It serves as a network proxy and a load balancer for services on a single worker node and manages the network routing, TCP and UDP packets. You see that proxy is doing all this work. It is a network proxy which runs on each network node, each worker node, and listens to the API server for each server, service endpoint, and creation and deletion. For each service endpoint, kube proxy sets up the routes so that it can reach to do it. You see that? So this is containing the complete our network environment over here. This manages the entire network between the nodes, pods, whatever you call this, and it works like a proxy, and it works like a load balancer, and it is doing the routing between the things using the TCP and UDP packets. And it is listening to the API server for each endpoint creation and deletions. For each endpoint, service endpoint, kube proxy sets up the routes so that it can be reaching it. So entire complete communication between the outside means like establishing the path, informations, everything is been done by the kube proxy along with proxying and load balancing things, as well as taking the API from the outside like this. Then the pods. Pod is one or more container logically go together. Pods run in the nodes. Pods run together as a logical unit. You can take it in any way. So they have the same shared content. They are all sharing the same IP address, but can reach other pods via local host as well as shared storage. Pods do not need to run all run on the same machine as a container, can span more than one machine. One node can run multiple pods. One node in the sense I'm talking about the worker node. Worker node can contain multiple pods. Okay, one node can run multiple pods like this. You can take it that way. A pod is one or more containers that are logically go together. Logically, we can group the containers into one pod. Pods run on the nodes. Pods run together as a logical unit. So they have same shared content. They are all sharing the same IP address, but can reach other pods via localhost as well as shared storage. Pods don't need to all run on the same machine. It doesn't require that it has to be running on the same machine. It can be spanning across other machine as well. One node can run in multiple pods. One node in the sense is here. One worker node. I take it as this is a one worker node. This worker node contains certain parts. This whole entire worker node, it is called as one worker node, but this is on one of the first machine. This is on second machine. This is on first machine only. Like this. That's what they say. More than one machine you can run. So this is one.
Does that machine one and machine one can share same IP address, right?
No, that will be managed. That will be managed by the Kubernetes. They all sharing the same IP address can each other, yeah. Via the local host they do that, yes.
But here I have a doubt. In a pod, of course, having multiple containers, right? Am I correct?
Yeah, multiple containers we are running it, yes, under the pod, yes.
Under the pod, so that multiple containers have different IPs, right? Then pod also have a IP address separate?
Pod is handling all yours. You see that they all sharing the same IP address, same content like that something. Pods are running on nodes. So your IP addresses are managed by your worker nodes and other things. They will manage everything on this. With the local host only, they will be talking to the another pod as well. Can reach other pods via the local host as well as shared storage. Pods don't need to run all in the same machine as a containers, can span across more machines. Like, so it's more of a logical unit only, right? So they will be managing inside.
Let's say if a few worker nodes are there. In let's say worker node 1, worker node 2. In worker node 1, there's a one pod, and worker node 2 also there is another pod. In that, not that one, that there are multiple pods in worker node 1 and worker node 2, right? In that, in worker node in pod 1, which is running in worker node 1, and there is same pod is running in worker node 2 also, right? Same containers are running to make sure the high availability and so on and so forth, right? And so in such occasion, but this it will communicate between these two nodes based on Docker the container, right? Not that pod, right? Am I correct?
Container level talking will be controlled by the pods itself, like a worker node itself, it will be controlling that. It's not like an individual container talking to the other way as well.
No, it's not. Yeah, true. But let's say same app. Let's say there is a load balancer in front. So you have to let's say one Ubuntu server hosted in worker node 1 and worker node 2 under the containers, right? So same same server. It's like, let's say auto scaling. Let's say servers are there in scattered in multiple servers. In such occasions, so we have in each Docker, each container should have an IP address, right?
Yeah, right.
So when it is being communicated, so that it will communicate based on the container, right? Not that based on the pod, right? Pod is that is significant.
Containers are sitting under the pod only. Pods are being managed by the worker node as such. The worker node has got some kind of a proxy information and other things. It can manage the container to container communications as well. That way, when it is, we have to see it in a broad level. Not one container talking to the another container. Means if it is as auto scaling, when it is getting increased, because the content is going to be the same one for all the things which we seen in AWS.
Yeah.
So you don't require to have that public IP address or any IP address assigned to those things to like log in from the outside to check on all the things. Because a proxy can manage all these things inside. Proxy can give one IP address, or load balancer can give one IP address to manage all these things. Logical units inside. That's why they say they have
that means master node, right?
Same shared content. That's how it goes on. We can see this very much and clearly when we are doing the lab. How does it getting like managed inside that when they are spreading across the multiple, one node like that, multiple nodes like that, multiple pods like that. Yes. Okay, next we'll go. Next slide. That's all. This is my contact information. Here, we have seen something very much of, like what I say, very much basic information about the worker node, master node, Kubernetes clusters, and what are the components inside the master node, and what are the components inside the worker node, and how the pods are getting constructed, how the pod can be spread across multiple worker nodes or something, how the containers are containing inside the containers are managed inside the pods which is in main components which we see under the master node and the worker nodes, and Kubernetes can be managed through the GUI, something that is very much possible. Where when we try to compare it with that Kubernetes with the Docker Swarm, there is no GUI comparisons as well. It is not possible. Means you cannot manage the Docker Swarm with the Kubernetes and other things. Sorry, Docker Swarm cannot be managed with the GUI or something. So this is about the basic things about the Kubernetes. But we need to construct it as a machine, like a master node need to be constructed, and slave nodes need to be constructed inside. Then we'll have to create some containers on that inside. Pod need to be created. Worker nodes need to be identified. Then we will be managing it through that GUI or by through some other commands and other things to do some orchestration stuff. Orchestration will be like the screen will be of containing a multiple, like multiple Docker containers, multiple worker nodes will be shown on that. We will be assigning the jobs to that area things, because as an user, we will be sending the API commands or CLI commands, or through the GUI will be issuing certain operations that need to be done on that, the worker nodes or something. Then we will be able to see that. But we need to construct a lab. Then only it's easy for us to know about what's actually going on there. Okay, this is not complete Kubernetes. This is about an introduction. Like I can say, they are about 30% of the things which we seen on the Kubernetes part of it. Kubernetes is an ocean. I understand. It's a big ocean. We need to understand by constructing masters and workers and containers and other things. But then we will be understanding that how we are going to manage the Kubernetes as a cluster, and how we are achieving the results, goals which we are looking for through the managing the entire containers. So, any questions on this?
Yeah,
it's not so full. I understand this is not complete one, but somehow you got some idea, like
yeah, I got a very good
because
idea.
we seen earlier, we seen the Docker.
Yeah, when it is being started, so I was in. Yeah, it's good that you did the Docker container first and then move to this.
Of course,
so
we have to start. No. Actually, whenever Kubernetes is coming, Kubernetes is going to do management of multiple containers. If I am starting as a multiple containers management is Kubernetes, then you'll ask what is container. Then what is container? Is a Docker is a container. So we need to start from Docker first. Docker containers, creating it, running an application inside, verifying the IP addresses assigned for that, killing them, starting them, stopping them, removing them, downloading the images from that Docker hub or something like that. We'll be running everything completely if you have the understanding of the Docker. Then you come to the multiple Docker, how do they form as a cluster, and how the cluster, like a Kubernetes orchestration platform, is doing the management of this. Then you will have the clear understanding of this. And we've seen many labs on the Docker also, which made you very much clear about that, how the Docker pull is happening, how the Docker push can happen, and what is the IP address has been assigned for a particular Docker container. How do we run certain applications inside that? These all we've seen that. The same way, we need to do multiple Dockers need to be put under one worker node, right? Then we will be constructing a like master node and worker node and other thing. Then we will be having the entire dashboard like that. We will go for that. Definitely, I will be showing a lab, but not immediately. It takes some time. Okay.
So I have one more question. That is what, let's say that how do we create pods? And I think that we have to create pods, and then thereafter we have to assign some containers to those pods.
Of course, yes. Of course, we have to create at least 2 to 3 machines on CentOS or Ubuntu or something. Servers need to get created. One is a master. We just need to make it up like that. Then we'll have to check how things are getting controlled by the other things or something. Or within that, if you have a good, a good infrastructure, means a heavy memory, heavy processing power and everything, because we are running on VM only again and again. We don't have anything on a bare metal or something. So virtual machine only we are running on that. So if we can control that and other things, and we can see it in the same machine itself, like creating a master and things, creating a dashboard over there. But we have to see that one. Then only we will be clearly understanding that how Kubernetes can be work in a clustered environment, and we can even go for like master and slave in the master nodes itself, like means like a HA activities between the Kubernetes container, Kubernetes orchestrator as well. Multiple master nodes, creating a multiple master nodes and verifying them whether they can fail over properly or something. That also we can verify that.
But and I think let's say that in a session that there are like 10 students are there. So each student will create one node in AWS platform, right? We have separate VPC. In that VPC, that each and every one of us will create, and we can. So I don't have to pay. I mean, big amount. I just have to pay for one node only, right? So then like that, so we can go ahead and do this practicals also as well, right? Let's say if you don't have that high level
infrastructure in local machine.
Infrastructure,
yes,
yeah.
correct. Correct. But installing, like creating the Kubernetes cluster, either it is in a AWS public cloud or in Azure public cloud, is a one click only. Just 1 or 2 clicks only. Very easily we can create that. That will be creating the master and worker nodes and other things. You can start working on that, but we don't learn much on that. That's why we just need to create it manually. Manually in a Linux server, we'll have to install all the kubectl and other other commands are there. We just need to install completely the Kubernetes first of all with using the commands. Yum install like that. We just need to do starting the service, verifying whether it is working on. Need to go through the logs and other things. That is, but what is the Azure and the AWS is offering is like a service they're offering. So they made many of the things which are already been constructed. So it'll not even take many time to bring up the things to work for you directly. But while you are doing on your own as a manually, you will be doing a lot of jobs and creating the complete Kubernetes cluster itself. That will give you the tremendous experience about like how the things are getting created on that. Rather than going for it is there. AKS something like that it comes Kubernetes cluster, Azure Kubernetes cluster something service is there, and in the AWS the Kubernetes service cluster service is there. We can start doing that. It is not a big deal at all. But you don't learn much of that from that kind of creations in the services because they think in the production point of view. You would like to create it in 5 minutes, 10 minutes or something to make it go for directly into the production or something. That's how. But learning purpose in the sense we need to create it with our own hands in our own servers. Go by one commands, running it, seeing the outputs, analyzing it. Then we'll go for API servers and controllers and etcd and the worker nodes inside that controllers and proxy, kube proxy, kubectl, and like pods, how the pods are getting created or something. So we should be seeing it in that way. Then we'll be understanding that. Okay.
These things are included in the DevOps syllabus.
DevOps syllabus, yeah, I try to include this also. Yes, of course, Kubernetes has to be shown. Otherwise, DevOps is not complete. Definitely, I will include the practical lab also. Because we done completely on Docker. Docker, there is nothing more than that. We've seen everything. Okay. But bringing up into the Kubernetes, it's a big challenger. We will do that. Why not? I'll do it. Okay. Any more questions?
Thank you so much.
No more questions from your side.
Yeah, no questions.
Okay. Thank you then. We will end up this session. Is it okay?
Yeah, thank you so much for the session.